Have you ever noticed what happens the exact second a teacher steps out of the classroom? The whispering starts, and within moments, the collective volume climbs into chaos. Usually, a student class monitor is left in charge, but trying to quiet down 30 of your peers is awkward, exhausting, and rarely works for very long. Someone has to constantly remind the room to keep their voices low. Doing that manually over and over causes friction and tension. Putting that emotional burden on a person is an ineffective strategy. To solve this, the room needs a tireless, automatic system that can keep track of the noise without getting stressed out. That is exactly why the classroom noise monitoring and warning system was built. It is designed to step in and encourage students to control their own volume. As you can see, this is a compact, assembled device that sits quietly on a desk. It uses a very familiar traffic light display to offer constant, silent feedback. It acts as a completely neutral third party. It simply measures the sound in the air and offers a warning only when the chatter crosses an acceptable limit. By letting this impartial digital helper take over, you remove the social friction from noise control. No one gets frustrated and no feelings are hurt. To understand how it works, it helps to think of the device like a human monitor. To do its job, it needs two basic things: ears to listen and a brain to decide what to do. The system's ears are a tiny microphone module. It doesn't understand words or record what anyone is saying. It only measures raw loudness, calculating how much sound energy is hitting it. That sound data travels to the system's brain, a microcontroller. Students write code telling this brain exactly how to interpret the microphone's volume data. Attached next to it is a memory card module, holding pre-recorded audio warnings waiting to be used. By linking these simple, off-the-shelf electronic parts together, you get a system fully capable of perceiving its environment, analyzing the situation, and reacting in real time. Of course, the device communicates its analysis to the classroom using a universally understood visual setup, a traffic light module. This chart shows how these levels work. When quiet, the line stays low, showing a green light. As volume rises across the first threshold, the display switches to yellow. If noise keeps climbing into the highest zone, the red light activates. But imagine someone drops a textbook. That loud bang could trigger a false alarm. A clever rule handles this. Quick spikes are ignored. To trigger the alarm, the classroom must stay loud enough to keep the red light illuminated for 15 straight seconds. Once that timer runs out, the device reaches out to a wireless speaker sitting nearby. It pulls a file from its memory card and plays an AI-generated voice clip asking the students to quiet down. Building this delayed trigger into the code ensures the device is fair. It ignores accidental, momentary sounds and only reacts to genuinely disruptive, continuous chatter. Giving students real-time visual feedback creates a distinct psychological benefit in the classroom. Because they can clearly see the yellow caution light turn on, students instinctively begin lowering their voices to correct themselves, long before the red light or audio warning is ever needed. The device acts as an objective guide. It helps maintain a quiet classroom by encouraging students to manage themselves, which reduces the constant need for a teacher or student monitor to step in and shush the room. This traffic light model is an excellent foundation, and the device has clear pathways for future expansion. Next steps in hardware could include adding a screen to show exact noise levels, or using smarter sound detection to recognize different types of noise. On the software side, the system could be linked to a phone app, allowing teachers to check noise trends and see how the class is doing over time. Technology doesn't have to be intimidating. With a few accessible parts and some straightforward code, everyday frustrations can be solved with clever, practical STEM applications.